Welcome, everyone, and thank you so much for joining the Energy and Sustainability channel. My name is Stephen Warren. I'm the CTO of Data Center Dynamics, and an absolute pleasure to be with you this time. We're really taking a look at something important, and that is battery innovation the catalyst for balancing resiliency and net zero, both? And that's going to be critical to look at because there was a wonderful article in The Economist just 2 weeks ago that looked at the power of AI, the power of chips, and how they're changing data centers and everything that's going on inside of our market. And many organizations are having ambitious targets to hit it. Sabey's on board too, and they're fantastic. So we're going to hear from them. But right now, I want to turn it over to you guys. We're so lucky. We have Aaron Schott, Director of Product Management at ZincFive. Harry Hanlon, he happens to be the Data Center Segment Manager at ABB. And of course, Dave Bruckner. Very, very lucky to have him, the Director of Engineering at Sabey Data Centers. So with that, let's get moving forward. If we could go to the first slide, and I'd actually like to turn it over to you, Harry. Harry, what are your thoughts? You see this all the time. You hear this all the time. You know this all the time. But what's going on here? I mean, what are the concerns? What are the trends? What are the disruptors? To you, sir.
There are a lot of trends we're seeing in the data center today. One of them is around AI, and everybody's talking about artificial intelligence, where it's going, the neatest and greatest chips. But what's that doing to the data center infrastructure? Specifically, we're seeing higher rack densities. We're seeing the demand for larger UPS modules. Today, UPS modules go up to about 1.5 megawatts. There's one manufacturer that has two. We see that increasing in the future with bigger modules coming out. The other thing that's happening with bigger modules is they're getting smaller in physical size. So we're getting a higher power density there. So that's going to impact cooling. But as far as batteries go, when we start getting into bigger modules, all of a sudden valve regulated doesn't make a lot of sense. And lithium has been the go-to for a lot of data centers here. We at ABB support lithium batteries. We think they're a great product, but we have some very serious concerns about lithium as far as supply chain and also safety. We've seen some jurisdictions that do not allow lithium, which becomes a problem. And so we really have been experimenting and looking at other sources. Lithium, there's a lot of demand from as we start putting more and more renewables on the grid. Lithium is really the only solution. And, you know, right now today, EVs, we have about 7% of the automobile population's EV. If we get a substantial there, that's going to put a big demand on the lithium. And we see economics of lithium going up in the future because of that great demand from energy storage and EVs. And we think there are going to have to be other solutions out there which are sustainable, can be recycled, and have a circularity about the product.
Ooh, we're going to get back to you on that one, Harry, when it comes to that circularity. Brilliant point. And boy, Harry, what a great point to make to people. Lithium is being used in so many areas, whether it's EVs or scooters or motorbikes or whatever. I'm seeing it here in New York. The bikes are everywhere. They're great. But what a great point to bring up. Lithium's needed everywhere. So if I could, I've got to turn it to you, Dave. A lot going on here. And Sabey is a wonderful player in this market. You are so good at how you've looked at it. I got to turn to you, Dave. What are your thoughts on this battery innovation? Is it happening? Can we do this resiliency and net zero? To you, sir.
I think it absolutely needs to happen. Talking to the disruptors, I'll echo what Harry said for AI. That's going to be very dense equipment. I think the other disruptor coming in is going to be liquid cooling. I think we all know it's a matter of time. As we talk about, sustainability, liquid cooling is a much more efficient means of cooling than is air, likely to use less energy per kilowatt. And, again, going back to the high densities, this AI is going to exhibit, air cooling will be insufficient for the chips. Talking about batteries, we did an in-depth evaluation of lithium ion batteries when they came out. We were very interested in the technology and what it had to offer. But at the end of the day, we opted to step away from it. We felt that the risks associated with it, the fire characteristics, Harry mentioned some jurisdictions won't allow it. Requires increased infrastructure for separation. to a somewhat lesser extent, they've not solved what the recycling will look like with those batteries. Remaining with traditional VRLAs, it's proven technology. It's generally reliable. They do generally have a good recycling program associated with them. But again, they have a finite life. I think most in the industry tend to replace those batteries at the 5-year point. So, there's cost, there's a certain amount of waste associated with that. Some years ago, we became aware of the nickel zinc technology that was starting to emerge. So we kind of kept in touch with it and really feel that ZincFive has tackled that technology and made it viable. And we're actually adopting it in our facilities. It offers, at least twice the life of a traditional VRLA battery. I visited Aaron and his team down at one of their factories. I think they have a good sustainability story as well as a good recycling story with those batteries.
Great point. And yeah, Sabey has tackled so many issues over the years, and thank you. And also congratulations, well done on expanding the Ashburn site and also the development down in Texas. Boy, Sabey's fantastic. Guys are wonderful. But
Thank you.
let me turn it to you, Aaron. There's a lot that was said there. Boy, oh boy, tackling issues. I love the fact that they brought up that liquid cooling issue because it's getting hot. How are we dealing with it? Aaron, to you.
Well, I think, Harry and Dave brought up some very good points for sure. First off, that with the increased power densities of AI, with UPSs getting larger, that takes more batteries and more cabinets to support a larger UPS, even for minimum run times. And thinking of the run times of today, 5 minutes is still very common, but we've seen a lot of people migrating to shorter and shorter run times just due to the fact that it gives you less cabinets and the ability to, with the reliability of data centers today and generators starting up in very short periods of time, typically you're not needing more than 30, 45 seconds to make the full transition to generator. So they're finding that as a point to remove additional upfront costs from the site and shortening their run times, and it's all in this goal of trying to achieve better dollars per megawatt in their builds, but also increase the sustainability of the facilities. If you can procure less equipment up front, it's less things that need to be built, less things that need to be shipped all around the U.S. and installed and started up, a lot less labor. So it's interesting that as these UPSs get larger and larger, different battery solutions still require quite a few different cabinets, and with nickel zinc and some of the other chemistries as well, the fewer cabinets you can get, the smaller the footprint, the smaller the facility becomes. But then you have to look at the additional costs of the safety equipment and code requirements that might be added back in for other technologies. Luckily with nickel zinc, it's a inherently safe chemistry, so you're able to gain a lot of footprint advantages, but also you don't have to add a lot of those safety features back in. So again, trying to reduce the amount of stuff that's kind of shoved into every room, reducing that overall carbon footprint of that design. And
Absolutely.
To your last point about the temperatures, it's interesting that as the world seems to be heating up here with climate change, or at least things are moving around. Places aren't as wet as they used to be. Things are drying out in certain locations. It really adds a lot of dynamics to the design of the facilities themselves. What ambient temperatures can you get away with inside of your facility? With the new battery chemistries like nickel zinc, you can actually operate your facilities at higher temperatures, and that's something that's really important for reducing your cooling costs. Maybe you can reduce the number of HVAC systems actually physically installed, or the tonnage, the KBTUs being removed from a facility, operate closer to that 30 or 35 C, or 95 to 104 F temperatures inside of your electrical rooms. Again, just trying to reduce your impact on your energy output, and increasing the overall PUE of your facility. So these things are becoming very important to look at from a sustainability standpoint. And new battery technologies are helping you get there. UPSs have commonly been able to operate up to 40 degrees C. So it was always kind of the battery that was holding the facility back as far as temperature. So these things are very, very dramatically changing with new battery technologies, including nickel zinc.
Fantastic. Yeah, what a great point. Let's move on to the next slide and get to this topic point. Every moment counts, Harry. All three of you have said it. The clock is ticking. More power, more cooling, more requirements, sustainability, energy reductions. I mean, even footprint reductions. Harry, how do I balance all this? When every moment counts, how do I safeguard resiliency and sustainability? What are you telling folks? What are you doing?
It's a great point on sustainability and resiliency, and they don't have to be in conflict. You can do both. And I think that's a very important point. And most of the data center customers have embraced that. A lot of the manufacturers are starting to embrace that as well, that it has to be reliable and sustainable. And that's one of the great things we like about the nickel zinc battery, is that this isn't something that somebody cooked up in a lab last night that's coming out and you're going to pull it on unsuspecting customers. Nickel zinc technology has been around for over 100 years. In fact, the first patent was done by Thomas Edison. So it's a well-known technology, and recent innovations in manufacturing processes made it economically viable. And ZincFive has done a great job of taking those original patents and really expanding the knowledge base and technology around nickel zinc, and has really come up with a very viable product that we've seen a lot of customers embrace with very good success. And as far as every moment counting, nowhere does it count more than in the construction process and trying to get things done. And being able to ship nickel zinc batteries already populated in the rack instead of like lithium where it has to be installed on site, that saves a lot of time. It also improves the reliability because the rack is tested at the factory, ready to go. It's not something that's assembled on site. So we think that has a lot of potential in helping the resiliency and also the sustainability, since nickel zinc is a very common metals that they use. Both nickel and zinc have high availability. And as was mentioned before, it's got great circularity and that it's easy to recycle. And so it has a lot of the great benefits that the valve regulated batteries had as far as sustainability and recycling and being a well-known technology.
Harry, I've got to ask, ABB is one of the top global players in this industry. It's just unbelievable. You're dealing with this also every day. You're dealing with embedded carbon and sustainability and your own scope requirements. Does nickel zinc help in your own areas of your own sustainability, your own global manufacturing, your own requirements?
We're seeing customers, and especially data center customers, really wanting to know what the carbon content is by product, not necessarily factory. And as we supply systems, including battery systems, we've got to do the scope 1, 2, 3 carbon. So yes, we're really focusing not only on our own carbon usage, but also the upstream carbon in our supply chain, from subcomponents, from third-party equipment like batteries that we supply with UPSs, is very, very important for ABB on our own sustainability journey, and very important for most of our data center customers who also publish their sustainability story as well. It's important for our end customers and for data center end customers.
Great, absolutely great. I'm going to turn it over to you, Dave, because I got to say right in front of everybody, Sabey has their own carbon reduction net zero requirements. You guys are great. And you're seeing this every day. So to you, Dave, what are your thoughts on this? The clock's ticking from you and also your own customers, because you're taking care of some biggies.
You're absolutely correct. So we have very aggressive goals. Our goal is to reach net zero carbon emissions by 2027. Our goals are primarily focused around scope 1 and scope 2, but in my role as well, I need to look at scope 3. So, Scope 1 involves, things like transitioning to green fuels, reducing fugitive, refrigerant emissions, and then also purchase of carbon offsets. Scope 2 gets into energy efficiency. Aaron talked how about battery temperature. In our electrical rooms, the key element we're trying to maintain temperature on is the batteries. They're the most sensitive component. VRLAs traditionally, they have a peak operating temperature about 77 degrees. I think lithium ion was going to be higher, but we've talked about the disadvantages of that. Nickel zinc offers a considerably higher operating temperature range. So right there, I'm reducing the amount of cooling I'm using in my electrical rooms on an annual basis. And then, in my role, I mentioned I'm focused on scope 3 as well, and starting to ask the manufacturers, what are you doing to address embodied carbons in your manufacturing process? And I have to admit, I've been pleasantly surprised with a lot of the responses I'm getting. The manufacturers are clearly being asked a question. They're clearly taking this seriously, and they're addressing it. And just, one way that I think the ZincFive batteries, contribute to this is the simple fact that if I can extend my battery life, by double, then that's that much less material that's being used to create the batteries, to ship the batteries to a site, the amount of labor installed with the replacement. I think it's one of the many contributors to net zero.
Perfect. Absolutely perfect. And by the way, Dave, I love the news. And by the way, the clock is ticking. By 2027, excuse me,
Yes.
20 years away. That's fast.
I am well aware of that.
Okay. Okay. I'm like, wow.
Yeah.
Okay, Aaron, to you, there's a lot going on here. I mean, clock is ticking for Dave, and at the same time, Harry's telling you how he's doing it all anyway. Aaron, to you, there's a lot to uncover. Please, sir, how do we even get there to safeguard resiliency and sustainability at the same time with all these different requirements?
I think it's really interesting because over the last 3 years, probably about 3 years ago, really, the number of people that were talking to myself about the sustainability of their facilities and looking for their scope 2, scope 3 emissions, and really the scope 3 from the manufacturer standpoint, it wasn't very large. But over the last 2 years, I mean, it's dramatically increased. I think almost every conversation I have with an end user is around the sustainability of the batteries. It's playing a much bigger part in the overall story from their customers' perspective to what we're pushing out and what we're trying to innovate and make better about our own technology is all about the sustainability. So when you think about battery technology in general, the longer a battery can last, that's absolutely beneficial to reducing or really spreading your initial emissions over a longer period of time, so you don't have to do the replacements or even the manpower to swap the batteries out much more infrequently. So having a longer life battery really reduces those overall amount of emissions. So 10-15 year battery life is extremely key. But also to the point of just the circular economy of the batteries themselves. What do you do with the battery once it's over? Once that life is at its end, can that battery be replaced easily, or does it have to be you pay someone to take it away and disassemble it, and hopefully they can recycle some parts of it. With nickel zinc, it's a pretty easy story because of the inherent safety of the battery. You can easily shred the battery and separate out the metals, the plastics, the electrolyte into their different types, and recycle the plastics and actually get reusable battery material back out of it, from the components of the electrolyte to the nickel and zinc electrodes themselves, and reuse those in manufacturing of new batteries. So that also helps reduce that overall carbon emissions, as well as the other things that are added into a battery. Where's the technology manufactured? What kind of mining processes do they use? Is there a lot of water usage or volatile organic compounds? And we actually went through the process of having a third party review all of our manufacturing and use profiles and try to put together a nice white paper on our overall sustainability. And what we look to see is, yes, nickel zinc does a very good job of this, but how can we make it better? How can we reduce that carbon going into the battery from manufacturing locations and trying to localize our batteries to the markets they're in, so that we have less shipping time and all those other different costs. So I think it's interesting from that standpoint, but all in all, the battery has to serve a purpose at the facility. It has to be, you know, safeguard that resiliency. I think we talked a lot about the sustainability, but the failure modes of the technology, and making sure that your battery lasts a long time and also can maintain your uptime requirements, I think is extremely important. So as Harry mentioned, having battery technologies that have been around for a very long time, that people understand how the chemistry works. We're just we innovated it to make it last longer in operation. I think that's a key point of the failure modes of nickel zinc are typically they fail closed, so you're allowed to continue the operation of data center even if you have a bad battery. So it gives you a lot of advantages that if you have a bad battery for any reason, you can replace it, and that battery can be recycled, and gives you a lot of flexibility in that design. So I think those are some real key points about the resiliency and the sustainability that battery manufacturers really need to think about in their own operations.
Great point. Great point. And think about it very, very carefully in their own operations, because it's impacting everybody else's operations. What a great way to put it. Let's get to the next slide, because you brought it up, Aaron, which is cost. Okay. And this is critical here. We're going to go by the numbers now. And this is, how do we get to resiliency and net zero and sustainability? But let's move beyond that also in the fact of what's economically viable for this. How do you compensate for a $40,000 chip, which is going to burn your building down because it's so hot? How do we deal with the higher cost temps? How do we deal with risk? What are the clients saying, and what are you doing? I love this expression. When we chatted last week, all of you said the same thing. There's a lot of unknowns. Isn't that fun? So with that, Harry, I've got to turn it over to you, because guess what? You love fun. But more importantly, Harry, you've seen this so many different ways. How do we build it in? How do we get it going? What construction? By the numbers, Harry. I'm just turning it to you, my friend. Please help.
Yeah, nickel zinc is a great product from what we've seen, from a first cost and a total installed cost process for us. Because of the circularity, because of the other things, I think a lot of customers can justify it from a first cost. Yes, it's a little more expensive for the product than the lithium, but again, having the rack assembled instead of having to assemble it on site with on-site labor saves a lot. So you really got to look at total installed cost, not just first cost. And when you look at total installed cost, it does very well. And as Dave and others mentioned, being able to operate that mechanical space at a higher temperature because of the batteries or allow you to go higher also improves your operating costs. So if you look at total cost of ownership, TCO, and look at ROI, it's really, most customers we've talked with that have looked at nickel zinc think it's a no-brainer. It really does well in that when you look at it from that equation. And most customers that we're seeing are looking at both TCO and total installed costs. They're important numbers for them, as well as complementing the sustainability story of their data center. So very important points.
Harry, are customers coming to you asking for those numbers, saying to you directly, give me the ROI, give me the TCO, I need to get these numbers down? Is that what you're hearing every day from customers now? That's a lot to deal with.
It is a lot to deal with, and we're hearing, we get a lot of requests from customers, not only for quotations on products, but they also want help with the information they need to run their TCO, information they need to have for their sustainability. So from our standpoint, we have got to be more attentive to customer needs in these areas and provide the information. And it is a monstrous task to get all that information together. from a manufacturer. When you're talking about scope 1, 2, and 3 carbon content on the number of catalog numbers a company like ABB has, and our competitors face the same challenge to do that. It's a lot to track internally in our manufacturing processes, in our upstream, in our third-party suppliers like ZincFive and other battery companies to try to get all that information out. It's a lot of information.
Harry, got to ask about UPS and backup gen sets. Can we use these new battery technologies and chemistries with our current UPS systems that we've got out there right now, our big cats? I mean, because the issue is coming up with the utility, because we're forcing the utilities to be green and we're trying to be green and everyone's green, but now we've got to actually look at the entire value chain of power. Is that something customers are looking at too with you?
We're seeing a lot of customers thinking about what can we do to replace diesel gens. They're not very sustainable. They're not very green. We've actually had, at least in the last week, several companies have been denied permits because they said, come on, it's 2023. Surely you can do something better than a diesel gen. And yes, there's some technologies out there, but to this point, we haven't seen them that are economically viable to replace diesels on cost. Several of the hyperscale customers are looking at different options like battery energy storage, fuel cells, others to replace diesel gens. And I think that's going to be the path of the future. But right now, the economically viability, the TCO numbers just don't add up. And so it's going to be tough for that transition. The industry is really looking for something to replace diesel gens. It's going to happen. I'm just not sure which stock tip I should give you as to whether to bet on a fuel cell company or a battery energy storage company.
Everyone listening in, Harry is ready to write down the names. Come on, Harry. You're taking care of my retirement, friend. Okay, I'm sorry. I got to step back. Dave, I mean, come on. You're Sabey. Cost to build per kilowatt, density. You ask every question you need to. You even design facilities specifically for your customers, BlackRock. Brilliant. Dave, you're handling a lot, my friend. How do you deal with this all? How do you deal with the numbers when you've got your own set of numbers and your customer set of numbers and your vendors? You're all trying to bring it together. Then you're dealing with all the issues of the locations, the jurisdictions. That's absolutely amazing. Welcome to New York. Thank you.
Yep. Well, I mean, you know, Harry talked about TCO, and that's a big one that goes on it. We have to look at first cost. We have to be able to build the data centers on day one, you know, for a cost that is, you know, that we can sell. If it's too expensive, we're not going to be able to sell it, and then we're going to have a very expensive, very empty facility. But you know, looking at something like ZincFive, we spent a great deal of time looking at what the total cost of ownership versus the first cost. Yes, the first costs are higher than traditional VRLAs, but not as much as you would think. And I think one of the huge elements that gives us some savings is how we deploy our batteries. They're installed in e-houses that are prefabricated. You know, they're manufactured somewhere else and then shipped to the site. VRLAs, you know, they're large, they're heavy. They cannot be installed at the manufacturer and then shipped with the e-house. They have to be shipped separately. So right there, there's some carbon emissions right there from two different shipments. There's the labor and the time to install on site, and invariably some quality control issues that can come up from that. Whereas we're finding with the ZincFives, the smaller footprint, the lighter weight, they can be installed at the factory where the e-house is being assembled. So there, you know, right there, your labor costs are going to be less because you're not doing the work in the field. Your shipping costs are less carbon emissions, less work in the field, which saves time and puts us closer to being able to energize that e-house and get ourselves into the commissioning process. So, you know, I think there's a lot of things that go into the cost saving. You know, there's the shipping, the labor, and just the time to delivery. So on that. And then when we get into the, the bigger pictures, we're, talking about backup generation, Harry is very absolutely right. It's getting increasingly difficult for us to permit diesel generators. We've been fortunate that we've been able to a large extent remain with tier 2, because tier 4 emissions controls almost double the cost of a package, and that goes into TCO. But we're being very limited on run hours. There was a recent article, I think everybody may have been aware of, the state of Maryland denied an exception to a large data center provider for a large quantity of diesel generators. And the way they're starting to look at it is, well, you're building a power generating facility. It's, even though we all strive to minimize the run hours, it's not cost effective or beneficial to us to run those diesels any more than necessary. But nonetheless, it's becoming a problem. Northern Virginia is having an air quality problem, and they're attributing towards generators. It's and then in certain jurisdictions they look at what you're permitted to run and then what you report on an annual basis and say, well, why are you asking for so many hours if you're not running them that? And while we strive to keep our maintenance hours down, what we're really counting on those units for is, that unplanned utility interruption, particularly one that's of a sustained duration that, nobody expected. The things we can do short term is transitioning to green fuels. We've looked at the hydrotreated vegetable oil diesel fuel. Conceivably, it has better emissions. The challenge with it is it's only manufactured in a few places on the West Coast. And so you have to have it shipped in. The availability of it for an extended outage could be questionable. A better alternative, I think, is natural gas generators. The challenge with that, of course, is that the natural gas delivery is not necessarily to the size, quantity, or location that we currently need it. And often to extend those natural gas lines is going to be, extremely expensive, and then would tip our TCO numbers over.
Yeah, great points. Thank you on all of them. Fantastic. I really like the way that you were saying that even the cost structures can change radically. And you, as the director of engineering, what you're seeing every day with every customer too. Hey, Dave, I got to ask, are a lot of customers you've got big customers, megas, the big fintechs. Are they walking up to you asking for higher density power requirements, HPE, HPCs? Are they asking for this AI chips? Are you looking at liquid cooling? Are you looking at this next stage?
So we are just starting to see customer RFPs that address AI, and we're finding that to some extent they're still trying to navigate the unknowns as well and determine what they need. We've for some time thought that liquid cooling it's not a question of if, it's simply a question of when. So with our new facilities, while we're still building air-cooled facilities, we are requiring the designers to include provisions that would accommodate liquid cooling.
That was great. Include provisions. Genius engineering, my friend. Genius. That was great. Aaron, I got to turn it to you. How do we get to the numbers here? How do you even discuss the numbers with people? You're dealing with utility concerns, operator concerns. And even now, I've got to say, you've got this relationship with Sense. We're even now taking a look at genset battery issues. So if you can go through some of these things, I'd appreciate it, Aaron. Help us here.
Yeah, I think it's important whenever you look at any technology, and Dave and Harry have really hit it on the head from numerous different approaches. It's all about the total cost of ownership, and that initial upfront costs and being able to translate it to your end customers in the long run. And from a battery standpoint, it can only help in so many ways, but we found that smaller footprints really dramatically decrease the overall build costs, and you can shrink your container, especially in e-houses for sure. The smaller the overall container footprint, the cheaper the shipping. The flexibility that you can provide by shipping complete is huge, because again, you can, when you're building an e-house, you're commonly building it some other location through optimized labor, optimize supply chains for those local facilities. So you're getting all those benefits from a sustainability perspective, and building that structure, but also allows you the flexibility that whenever you're building your facility, you can like Legos, just stack them up. And that we've been talking about that for years. But
Yeah.
whenever you do that, you have all this commissioning and startup that's done at these integration facilities. And then if you had to go and take the batteries back out and then ship them separately, there goes to your, again, adding more carbon to the whole chain and more costs. So being able to ship complete is big. And then operating those e-houses or even your traditional built data centers, higher temperatures, those reduce a lot of costs. And what we found is you can look at it from installation labor and the cost of the cabinets and then the parts and pieces that are added in, but it becomes very dynamic with every customer kind of doing something slightly differently. That from a by the numbers looking at it, even if you were to break even, the benefits of a non-flammable technology that really has really great UL 9540A, no thermal runaway story like nickel zinc, there's a lot of added benefits to the safety of the site and the cost there, but also the operating temperatures and what that means for your facility and the overall lifetime costs that's going to reduce you, as well as your scope 2 efficiency benefits from operating that facility at such a higher temperature. But I think all in all, it's just trying to drive as much cost out of the upfront, and then hopefully throughout the life expectancy of the batteries, you're able to gain even more. So when people are looking at these TCOs, that's really what they're kind of trying to justify, that maybe a little bit uptake in upfront costs from the battery perspective, but all the savings are gaining from the infrastructure savings and then the life cycle savings of 10, 15 years in operation from maintenance and service, and then the recyclability of the battery at the end, reducing all of that even more with getting valuable metal values out of the battery at the end, just like you would with a lead acid battery. You can do that with a nickel zinc battery. I think the story's still out for lithium ion, what that's going to be in the future, but it's changing every day. The other point I kind of wanted to address was where the batteries are being utilized at the UPS, at the gen sets. I think there's a lot of flexibility in the facilities for different types of batteries. At your traditional UPS, you're going to have your battery system there. A lot of end users are migrating to in the rack battery backup units for like OCP style installations. And that changes a lot of, especially with these AI chips, changes a lot of the design requirements for the localization of the battery into the rack. And maybe that rack can now be operated at higher power densities because you can install more batteries specifically for that unit, as opposed to increasing the runtime for the whole facility. So it gives a little bit of flexibility. I think that the key with in-rack battery backup units is the safety aspect of battery technology, because as people migrate more to these AI chipsets or getting the batteries on the floor with all this revenue generating equipment, the safety of that equipment is paramount to the whole operation of the facility. So I think that's as you're looking at these by the numbers, that that you have this overall total cost of ownership, but safety plays a huge role. And then the sustainability aspects just are kind of the icing on the cake of the whole installation. Because if you can save money, have a great TCO, and also reduce your overall carbon emissions and have a good circularity of the battery technology, I think that's going to pay off in leaps and bounds over the lifetime of the facility.
I gotta say, I love the word payoff. It's gonna pay off sometime. No, it's gotta pay off in the front. Dave said it great. First cost. The payoff has to begin right at the first cost. No games here. Okay, Harry, let's go to the next slide, please. I apologize. I'm getting told that we're running out of time. So we're right at the ending where we got to have our call to action. So with this, let's get right to it. What should we be doing? Harry, you're in control, my friend. You tell us what we better be doing right now. Please, sir.
I think we need to be paying attention to carbon content of product. We need to be doing that. We need to be focused on sustainability. There's definitely a call of action across the industry. And we better keep tabs on what's happening with AI. There are a lot of things that we know about AI, but the unknowns far outweigh what we know at this point. And I don't think anybody has those answers yet as to where it's going, what it's going to do. What are some of these data centers going to look like? We've touched on some of the impact of data center design, but I think there are more. You know, one of the things we've heard is that we're not going to have nice, stable, flat loads in data centers in the future. That's going to be very important when we look at different strategies. You know, if you've got to for example, incorporate that for the peak load of each rack on your battery storage, that may require more batteries for an OCP type design than it does for centralized. I don't know that that's the case, but that's one of the things that customers are going to have to look at and see and figure out how that's going to work. So I think as we go through, we've got to continue to be innovative. We've got to continue to pay attention to sustainability. We need to pay attention to how we build products and how we design. We've got to design carbon out in the manufacturing process, in the supply chain. This is going to be a bigger revolution than I think a lot of people are aware of, from top to bottom through the industry, to try to meet the sustainability goals that people have.
Harry, are you telling people to get in contact with you as fast as possible if they need help?
Absolutely. We're here to explore these issues together, to try to problem solve and find out what's the best solution, not only for today, but what are you going to need for tomorrow?
Great point. Absolutely great point. Dave, I'm going to turn it to you. Wow, unique position that you've got at Sabey and a fantastic firm. How do you take a look at this and what's your actions? Your own actions, but also your massive customer actions too that are responsible for the e-commerce society we all live in and love.
Well, I think from a provider standpoint, looking at embodied carbons in all the equipment we purchase and reaching out to manufacturers, and manufacturers need to be able to provide metrics about how they're actually reducing carbons in the construction process, and I don't want to use the phrase to tell a story, because they could just be doing that very thing, but actual meaningful metrics. And as I mentioned, I've had at least a couple providers that were, they were able to, quantify what they've done, not just, in the last couple of years, but be able to compare it to 20 years ago. They've done their homework, they've gone back and they've said, what were our carbon emissions 20 years ago and what are they today? And so I have to be very conscious about looking into suppliers that, what can, give us meaningful data on carbon reduction, and at the same time, not doubling the price of the product to do so that, our TCO doesn't work. We have to be ready for these, these emerging technologies as they are, such as AI and water cooling. How do we be ready for that? What kind of other disruptors may come up to play in this? The big one I think too is for us, we've touched on is backup power generation. We have to figure out how to phase out diesel generators. And I think to the largest extent, that's going to fall on the diesel manufacturers, because they've got, sunk capital in these large, manufacturing processes. How are they going to be able to continue to use those facilities and create backup power generation that helps us, paint that renewable picture?
Dave, that was great. How do you paint that renewable picture when it's already embedded inside your designs for all these years? How long have we been doing this, Dave? Forever, it seems. We've been sticking Jensen in. Now they're telling us no. And that's why Aaron is so wonderful. Aaron, last comment to you, sir. We're right at the end. And I got to say to everyone, to you and to everybody at ZincFive, thank you for all you do. You've got the last word here. And then a big thank you to all the guys. But Aaron, to you, sir, take us away.
Yeah, absolutely. I think the metrics of what it takes to build a data center are important from looking at the embedded carbon footprint. But not only that, it's finding out from an industry what things uh, really mean sustainability. We're not looking to try to just greenwash by throwing certain numbers here and there, but we want to truly think for a sustainable future, what can we do better as a manufacturer and making our batteries less carbon intensively, but also using less water in the manufacturing, less volatile organic compounds, all the things, less harmful chemicals as well, and try to remove those from our overall sustainability environmental impact of our batteries. But it also comes to what do end users really need from manufacturers to see? Is it what kind of metrics, what kind of comparison can we do to make ourselves better and to make your decisions easier from a sustainability standpoint? Is it purely just looking at how much carbon is embedded into that device, or this part and this piece, or is it the whole story, the whole life cycle, the whole recyclability, the whole circularity, how to reuse and reduce components, physical infrastructure, you know, energy loss throughout the lifetime of a solution, as well as that end of life wrap around back into manufacturing new products and solutions for the data center industry. I think all these things play such a crucial part of creating a sustainable data center infrastructure that the world really truly needs, especially as we've seen the numbers. It's not stopping anytime soon. Production is going to be more and more data centers, more and more megawatts, and it's just going to take up more and more electrical usage from all of the generation facilities around the world. So it's key for us to make these changes and adopt these technologies. Otherwise, we're doing a disservice for the future of humanity.
It's happening everywhere, Aaron. You got it. You hit it. You hit it so good. It's happening everywhere. And with that, we're finished. To everyone who's joined us, thank you. But remember, I got to say to Dave and to Harry and to Aaron, thank you guys so much for joining us. Great conversation. And remember, you said it. There's a lot of unknowns, and the best thing people can do is contact you as fast as possible. Time's running out. Thank you. Well, thanks everyone for joining us. Much appreciation. Don't forget, you can get everything on demand. But look, coming up right next is our next episode, a fireside chat where we're looking at the journey towards sustainable data centers with a focus on cooling architectures, how absolutely critical after what we just talked about. And of course, we've got a fantastic speaker lineup, our very own Peter Judge from DCD as well, McCullen on from Johnson Controls International. Please join us right at the top of the hour. Thanks so much.